All right, moving on, continuing the theme of history and vegetation and climate change and how we're maybe in the Dust Bowl now and we didn't even know it, and we're no longer the moist forest, but maybe we were not the moist forest at some other time in our history as well, and that's the kind of thing that Buzz can talk to us about. He's going to be giving you a 3,600-year history of vegetation and fire dynamics from the Bull Run Watershed Management Area. It's up on the Mount Hood National Forest. So he's with the Portland State University. So help me welcome Buzz Nanavati.
Hello, everyone. It's great to be here. First and foremost, thank you so much to the Portland Water Bureau and the Mount Hood National Forest for being part of this project. It's an absolute privilege to be up in the Bull Run, and the conversations that have followed have been fantastic as well. So yeah, 3,600 years in 20 minutes. Let's do it. Okay. Yeah. That's fine. Cool. All right, so today I'm talking to you with my paleoecologist cap on, which means that I rely a great deal on records like pollen and charcoal and other little bits of plants that fall into lake sediment and gets preserved through time. And this project essentially got its start with a relatively, at least to me, simple question that Professor Andres Holz posed to me in a meeting. With the 2020 wildfires just in the rearview mirror, how did past ecosystems recover from fires in the past, right? It seemed relatively simple enough to me, and so the first thing that I jumped to was the wealth of research that's been done in this region. There's loads of sites. And so here you can see just a selection of those sites and their interpretations. Each individual site here is plotted next to each other, and then the y-axis is time, the top being present, where 0 is 1950 Common Era or AD, and the very bottom is about 15,000 years ago. And so the period that I want to draw your attention to is between about 11,000 and 7,000 years ago, which is this period when we had just come out of the last ice age, temperatures quickly changed, quickly warmed up, summer incoming solar radiation was at its highest, and all of that resulted in a period where we had high fire activity relative to the rest of this time period. And this resulted in some pretty interesting plant communities, including abundances of Douglas fir co-mixing with alders, and then loads of other open forest taxa like grasses, ferns. But a lot of those studies, the resolution for those samples are between 100 to 500 years per sample. So this doesn't really help us address our question of what happened after each individual fire event, asking questions about what is succession in this paleoecological record. And that brought to the forefront in our head this idea that we need to go back and kind of do what Megan Walsh has done in other places, where we look at higher resolution samples for pollen to try and get at this post-fire successional narrative, which Andrew and Brian have already highlighted very well. And really just kind of looking at this question of what happens? Do you have this quick sort of regeneration of forest following a fire? Do you have your forest kind of having to compete with shrubs for decades before it starts to recover? Does your forest have to fight against alders before it actually has a chance to recover? Or do you have this hodgepodge mix of heterogeneities, different fire sizes, types, that result in a very complex narrative? And then throw on top of that all of Alan Tapley's work showing that just depending on the fire severity, you can achieve any of these goals by any number of means. So it gets really complex really quickly, but what does this look like in these longer term records? And so to address this, we turn to Upper Goodfellow Lake, which is in the Bull Run Watershed Management Area. And we chose this site because it's kind of in that ideal sort of analog for some of these landscapes that burn, this mesic Western Cascade ecosystem dominated by Douglas fir, Western hemlock, Western red cedar, and then as you start to go higher and higher, especially Pacific silver fir in this area. And on top of that, the Bull Run watershed itself is an incredibly important water source for the Portland area. And this area was particularly chosen because of the wealth of dendroecological research that has also been done, pointing to these large burned areas, especially 1493, when we have the Bull Run fire event. And you can see the location of Upper Goodfellow Lake shown in the little circles. And you see that that site may or may not have actually burned until 1873 after that. And so a fire like the Bull Run is something that should show up in our records. So we were really excited to go and core that lake. And so here's a map showing the lake's location. You can see that just to the north there's a nice big hillside, and same to the southwest there's a small one. And we hypothesized that if you had big severe fires burning across those hillsides, we'd have increased erosion into the lake. The lake itself is about 3,000, just over 3,000 feet in elevation, and about a quarter mile in diameter, which makes it a great repository for pollen and charcoal from within 3 to 5 miles, with a bulk of the pollen and charcoal coming from within 1 mile. And so we know based off of information sent to us by the Forest Service that this area was logged between the 60s and the 80s. But still to this day, you can clearly see where that hillside is. There are still some pretty old stands there, the red locations being higher, older canopy layers. And so getting into the bulk of the data here, one thing I want to walk you guys through a bit is the context of temperature change over time. And so here I have plotted a series of 3 different temperature reconstructions that show essentially a scaled anomaly, so kind of like a z-score of the temperature. And the very top being recent, so kind of that 0 being 1950 common era, if you can think about it like that. The very base being 3,600 years ago. What we have is a general decrease in temperature through time. And then right about 1,000 years ago, we have a brief warm period. This is referred to as a medieval climate anomaly. It's a warm period that shows up throughout the northern hemisphere. And then we have a statistically significant, like a major cold period called Little Ice Age. And this Little Ice Age period, based off these hemispheric records, generally suggests some of the coldest conditions in thousands of years. And it's interesting to keep this in mind because the bulk of our old growth forests either established then or lived through that period. So turning to the charcoal record, our understanding of fire deeper back in time, what we see here is charcoal accumulation rate, essentially the amount of charcoal accumulating in the lake through time. And once again, plotted by depth and by age. We see really clear peaks, and you can see statistically significant peaks in charcoal, like basically what we counted, shown as the pluses and minuses. The minuses just being peaks surrounded by some pretty noisy data, so there's a little bit of uncertainty there. And in general, what we see is fire frequencies as frequent as 200 years per fire initially, and then it's slowing down. And so this is the time when I want to point out that a peak in charcoal, as we interpret it, is a statistically significant fire as far as the size, severity, or proximity to the lake. And so many of the fires that Andrew talked about earlier, these low severity, smaller fires, are missed with this method, at least using the peak detection method. And so we see a thicker peak about 1,700 years ago, 1,800 years ago, which could have been multiple fire events back to back to back over about a century's time. And then another bigger peak followed by a couple subsequent smaller peaks. And then right about 500 years ago, we have a peak. That's the Bull Run fire, so we assume. And the very uppermost peak, that's actually likely a signal from the slash burning following clear cut in that area. And we can also use a proxy to talk about soil erosion into the lake. And we use magnetic susceptibility, which is essentially the minerogenic input of surrounding soils into the lake itself. And what we see is after that fat charcoal peak, right about 1,700 years ago, we have a period of a few hundred years of increased erosion. And then it kind of drops back down to low levels until what we believe to be the Bull Run fire. We have another massive increase in erosion. What's going on with vegetation? So vegetation is plotted along the x-axis, each taxa, and then the values that are being presented are in percent abundance. And the fine dashed lines kind of shadowing the darker volumes are exaggerations that show like a 5 times exaggeration so we can see what smaller attacks are doing. The horizontal dashed lines that you see are statistically significant changes in pollen assemblage, which we interpret to be very important changes in what the ecosystem looks like. So initially what we see is that there was actually surprising amounts of pine early on. This was likely pine being blown up from the Sandy River Valley, so being blown uphill. But in general, what we see from about 3,600 years ago to about 2,000 years ago is an increase in our western hemlock. And after that thick peak in charcoal, we have a massive decline in hemlock, followed by an increase in alder, followed by an increase in Douglas fir, followed by the recovery of western hemlock, kind of like that textbook narrative of post-fire succession. Happened once. Fast forward through 3 more fires, we now have a landscape where Douglas fir is starting to do better. We start to have western red cedar starting to do better. And remember, that time period was a little bit warmer, transitioning to a period that was quite a bit cooler. And that final transition to that cold period is associated with that Bull Run fire. And so that Bull Run fire occurs during this colder period, and we see this surprising post-fire succession narrative here where we have our increase in alder, yes, but what's happening with Douglas fir? It's not increasing yet. And what we actually see is western hemlock outpacing Douglas fir in its recovery. Why does this happen? One possible explanation is that seed sources remained, so perhaps when the Bull Run fire burned, this lake was just right on the perimeter of what was mapped out for the Bull Run fire. So perhaps this part of the Bull Run fire, yes, it was close enough to cause a statistically significant peak, but perhaps it just wasn't as severe. Perhaps it left some western hemlock alive and allowed it to propagate relatively quickly. Another way to look at this record is by using different pollen ratios to get at different narratives. And so here we have charcoal plotted along the x-axis with present, once again, like 0 being 1950, common era, on the left, and 3,600 years ago on the right. The black line is charcoal. We have our peak still marked. The green line is a proxy that we're calling our old growth proxy. So it's basically a ratio of western hemlock to Douglas fir, with more positive values equating to more western hemlock, lower values, more Douglas fir. The orange, a proxy for canopy closure, essentially western hemlock to grasses and ferns. And so what we see is that after the first few peaks, we have a relatively open landscape that first we have that big increase in Douglas fir, and then we have a period of over 1,000 years where western hemlock is just hanging out in a relatively closed canopy forest, regardless of multiple fires occurring. We do see ticks up and down, and some even associated with fires, but it maintained, it persisted. And what we see after this big fatty of a fire event at 1,700 years ago, 1,800 years ago, is a massive decrease in canopy cover, a massive transition to early mid-successional types, including more Douglas fir, followed by post-fire recovery, which we discussed. And then after a series of 3 more peaks, we have a decrease in canopy, a decrease in our western hemlock towards a more mid-successional sort of narrative. This is occurring during this medieval climate anomaly, this warm period. And then we enter the cooler Little Ice Age, and that's when we have our peak with the Bull Run fire, which is followed by a very quick recovery of western hemlock in this equation. Another way we can look at this is through a superposed epoch analysis, where this the dark black line is our 0. That's basically the point at which we have a peak in charcoal. That is our fire event. Then the x-axis, we have negative 200, positive 200. Those are years. So to the left, we have years before the fire. To the right, we have years after the fire. And so in general, what we see, with the blue line being a smooth trend of the means, like what's going on, and the dashed lines being the 95% confidence interval. So what we see is that alders tend to quickly recover within the first 200 years of a fire. Douglas fir is not as clear. Douglas fir, in this particular ecosystem, with this particular statistic, didn't appear to be as affected as we expected by fire. And also did not recover, or it just recovered much more quickly. Western hemlock quickly declined and then took centuries to recover. And perhaps even in general, taking more than 300 years to return to its pre-fire state. But what's also important here is that there is a great deal of variability surrounding all this. And I intend to play around more a little bit with the statistics to try and figure out if we can kind of narrow that variability, but variability seems to be one of the buzzwords today. So some conclusions and takeaways from this, starting at the bottom of the core, so earliest in the core, from about 3,600 years ago to 2,000 years ago, pine, open forest taxa abound. They give way to mesic, more late successional communities. And during this time, fire was varying. These large, significant fire events were varying between 200 and 400 years. So this, in my mind, may have looked more like this uneven cohort, heterogeneous fire event. There's a lot going on in the landscape, a lot of complexities. Then we have our textbook case that happened once in 4,000 years. It's the allness to Douglas fir to Western hemlock narrative. Then between about 1,400 years ago and 800 years ago, we start to see a little bit more variability in what's going on with the climate, as far as the temperature, I should say. And between these changes in temperature and changes in what's going on with the fire, as they're becoming perhaps more dominated by mixed severity, low severity, more frequent fires, we see a lot more variability going on in the landscape. Then we had the Bull Run Fire, 1493. This happened, once again, at the beginning of that cooler period. It's a lot more difficult to say what's going on because we don't see something that we didn't expect to see, alder giving way to Western hemlock giving way to pseudotsuga. So I kind of suggest here that we likely had a mix between two narratives going on, and it'll be nice to tease that out more as we go ahead. So I'll just leave you all with kind of a cautiously optimistic takeaway here. Western hemlock forests have persisted for at least 3,600 years in this landscape, regardless of these changes in fire and small changes in temperature. However, with current, present, rapid increases in temperature, there is some evidence out there to suggest that we should be concerned. So that's why there should be some caution with this optimism. And so I'll stop it right there and take any questions.
Plenty of time for questions. Plenty of time. Everybody's heads.
So, yeah, since we're waiting, I'll also bring up that we do have some future work. We do have some work that we're doing right now at Gordon Lake in the Willamette National Forest, and Mineral Lake closer to Rainier. And as part of that project, we're actually working with DNA specialists. So we won't just be talking about vegetation and fire. We'll be able to address everything from algae to elk, hopefully. So a lot coming out soon. Yeah, as far as talking about the difference between this record and other paleoecological studies in the area, the main difference is in the sampling resolution. Megan Walsh has done some high-resolution research in the Willamette Valley, but this is going a little bit higher in elevation to the Mesic Western Cascades. As far as things that we're learning from this that surprised us, it's the resolution of information that we're getting that is like really the novelty of it. So we would likely have missed the fact that Western hemlock outpaced Douglas fir following the Bull Run fire in our records had the resolution not been better. We would have assumed that post-fire succession would have followed the alder, Douglas fir, hemlock narrative for every large fire in this record would we have sampled at I'm doing air quotes for the people who can't see me, at a normal sampling resolution. So anything new that we are providing is coming from that, and so that's basically these dynamics between post-fire recovery, not necessarily looking how we expected it to look, and then also being able to provide a kind of a chronology of saying it takes 300 years in these records, and that itself varies between peaks. So, yes.
Hey, Buzz.
Hey, how you doing?
So, in your cores of Goodfellow Lake, were there some other constituents you saw in those cores about inputs from outside sources?
Are you referring to what?
Volcanic ash.
Oh yeah. So
Other parts.
I don't know if you have my slide still. Anyone? No? I do have a supplementary picture. So we went back Thank you so much. We went back this past summer and collected a 6-meter long core that went back likely 14,000 years. And one of the cool things about going back that far is you go through the eruption of Mount Mazama. And so we have a 2-inch thick deposition of ash from Mazama. And then going back farther, I believe it's Ashcroft Butte, Ashoft Butte, that's right next door. We have some like pretty honking big tephra depositions that could have been from that as well. So there's definitely input coming from other sources like volcanic sources. Absolutely. One more question. I can't see anyone, so I think we're good. Cool. Thank you.